Hello everyone, and welcome to today's webinar introducing Linkurious entity resolution. So let's get started. So first, a quick word of introduction regarding Linkurious. The company was founded in 2013. We have two offices, one in France and the other in the US. We are a team of 50 plus employees. And on a daily basis, we are supporting more than 10,000 investigators worldwide who are using all solutions to make sense of complex connected data. Today, for this webinar, I'm going to be joined by Jeff from Senzing. Jeff, I will let you introduce yourself.
Hello, I'm Jeff Jonas. I'm the founder and CEO of Senzing. I call Las Vegas home. I'm in Hollywood at the moment. So just a quick introduction to the company. My team and I back a few decades ago used to be headquartered in Las Vegas, and we had built software for the casinos known as non-obvious relationship awareness. It was helping the casinos combine and link data about customers and bad guys. This technology started finding things that were unusual and amazing. It developed quite a reputation. We eventually did a round of venture capital with Reed Elsevier, the parent of LexisNexis. They led an A round, and then in 2005, we sold our entity resolution company, our fifth generation technology, to IBM. So there we are, that's in 2005. I stay at IBM, I'm the largest shareholder, but I love the team, I love the work and what the technology does. In 2009, we suggested to IBM that for $50 million, we could build a sixth generation technology. We codenamed it G2, not for generation 2, but for genus or species 2. It's just so radically different. And they commissioned it. We started building it. We started shipping it in 2012 through IBM, but in 2016, they let us spin us out. And from 2016 to 2018, we were back in stealth. And in 2018, Senzing launched and became, known to the world. We're the only entity resolution technology out there today that is really built as a software developer kit that you can just plug in. It's all we do is make entity resolution easy for developers. And our customers are public sector and commercial and big businesses and small businesses, cloud and on-prem. But growing is our partnership relations, like being here today with Linkurious.
Thanks, Jeff. So today's agenda, a quick recap. We will talk first about what is entity resolution. Then we'll talk about entity resolution in Linkurious. Then we'll do a deep dive in entity resolution and show entity resolution in slow motion. And finally, we'll do a bit of a demo where we will apply entity resolution to a real-world data set, the Panama Papers. So let's get started. So first, what is entity resolution? What we believe in at Linkurious is in the importance of context. And you can see a bit of an example of that here. You have a person on the left, seemingly a good normal client, but I can look at the relationships of that person and see that he is indirectly connected to a non-fraudster. And when I understand that, when I understand this contextual information, I'm able to understand that that seemingly good person is maybe a potential risk. And that's the sort of insights that we want our clients to achieve at Linkurious. And entity resolution plays a key part in that. And I'm going to talk about this a little bit more in a few seconds. Here you can see an overview of the Linkurious decision intelligence software. And you can see on the left internal data and external data that are flowing into the platform. And that's where we combine entity resolution, AI and graph analytics, but also alerts and case management capabilities and search and visual investigation capabilities. All of that to make sure that the analysts were tasked with making sense of today's most complex data problems can make confident decisions very quickly. So I've mentioned entity resolution, and I want to double click on that now and provide a first definition of entity resolution. So entity resolution, it's really two things. First, it's recognizing when multiple records that are slightly different are nonetheless related to the same real-world entity. And we can see an example of that on the left. We have Bob Smith II and Robert Smith Jr. They have sort of the same street, same address, but it's slightly different, and sort of the same phone number, but it's slightly different. But when looking at all of this information together, I'm able to make a pretty confident guess that these are actually one and the same person. So that's one aspect of entity resolution. And then another aspect of entity resolution is, and it's related to that, it's understanding when multiple records, despite being fairly similar, actually not related to the same word entity. And we have an example of that on the right. We have yet another record, this time describing someone who apparently lives at the same address, but has a slightly different name, Robert Smith Sr. And here we are able to make a reasonable guess that this is indeed another person, another real-world entity. So 3 records, 2 real-world entity. And that's what the entity resolution process is all about. Entity resolution, maybe you have heard some related terms in the past, because there are actually a lot of names to describe this process. Can be deduplication, record matching, deduping, entity linking, identity resolution, fuzzy matching, and more. All of these terms are related actually to the same concept. And now let's see an example of entity resolution applied to the graph space. Here we can see a subgraph on the right with I guess six nodes. We can see another subgraph here on the left. And when we look closely at these 2 subgraphs, we can see that some nodes exist in the 2 subgraphs. And when we apply entity resolution, we can identify the commonalities, the nodes that exist in the 2 subgraphs, and get to a more condensed, a more streamlined version of the data when everything is brought into a single graph. And as a result of that, I can then dive into some other relationships that I wouldn't have been able to identify otherwise. So that's an example of applying entity resolution to graph data. So I've mentioned entity resolution, but now I want to talk about why it exists in the first place. And there are a few reasons for that that I'm going to talk about. For example, the data can come from different data sources. So for example, we can have some data that's coming from an internal client list, and we want to merge that, to combine that with an external company registry dataset. Here, we will definitely need entity resolution because there are chances that some real-world entities will exist as records in the two distinct datasets. So that could be one reason for the existence of duplicates. Another reason can be that the records that we are manipulating do not have a common key, a common unique identifier. For persons, one such identifier can be the passport number that should be unique to each person. And when we have that, and when this information is accurate, we can use that to deduplicate entities in a very easy fashion. But it's not always something that's available. Another issue is that just the notion of name frequency. Your name, whether it's the name of a company, the name of a person, it's not unique. As an example, there are more than 33,000 John Smiths in the US alone. Another issue can be natural data variation. In the US, a Bill or William can refer to the same first name. There can also be data entry errors. Someone can have a fat finger problem and accidentally mistype his or her name. There can also be cultural differences in data. A single name can be spelled and written differently in Mandarin or in Cyrillic or Arabic. And then there are temporal data changes. For example, someone can get married and change his or her name. And finally, and that's of particular interest for us, because we are interested in a risk and criminal behaviors. There can also be attempts at misrepresenting the data, intentional misinformation. So someone who wants to commit fraud is probably not going to use his or her real name and will probably use an alias instead. So for all of these reasons, we can end up with duplicates and thus a need to perform entity resolution. And entity resolution, it is very, very important because as more and more data is combined into context, the analytics, the alerting, but also the investigation work, all benefit from the ability to correctly bring together various data sources and the ability to deduplicate records. There's really a multiplier effect that comes with the accuracy of data. And this aspect, this value of entity resolution, it's particularly true in the context of risk-related use cases. Because, and we mentioned that earlier, sometimes there's international obfuscation, and entity resolution can help detect that. Entity resolution can also help accelerate investigations, quickly find connections that you would otherwise spend a lot of time looking for. And finally, entity resolution is critical when it comes to combining internal data with external information about politically exposed person, company ownership, or more. So for all of these reasons, we strongly believe that entity resolution is really important at Linkurious. And I want to provide an example of that with a very simple demo, I guess. Here you have two organizations. You have MomCorp, which is owned by Acme Inc. And I can make a risk assessment on these companies just based on this internal data. Maybe also have some extra information, such as the name of the ultimate beneficiary owner of these companies, Mr. Smith. But if I'm able to leverage entity resolution, I will probably be able to identify that Mr. Smith also exists in another data source, external data source, and that these two Mr. Smiths are actually one and the same. And then maybe also via access to this external data source, I can identify that Mr. Smith is connected to two other companies, and that is a partner of Mr. Zukov and Mr. Gamian. And then in turn, if I understand that Mr. Zukov and Mr. Gamian are a risk, then it's just going to impact my risk assessment of MomCorp and Acme Inc. And there you have it. You have a very simple example of how the combination of entity resolution and external data can bring insights that you would otherwise simply miss. And that's what we want to deliver by integrating entity resolution capabilities in the Linkurious platform. Jeff, over to you.
Yeah, there's three general ways that companies have been approaching entity resolution in the past. One is what you might call lightweight data quality software. This is software that's going to look for keys that are the same, like the same passport or the same driver's license. They're going to have a limited ability to compare complex names, structurally different names, and tend to not deal with things where there's arrays, like 5 different names, 3 different dates of birth, 6 addresses. So that's one kind of class of software. The next, and maybe the most common one that we run into in the world, is people that have just been building their own internal entity resolution. And what these projects typically find is, as you go from 5 people to 10 people to 20, I know organizations that have 50, 100, even one organization has 200 people working on entity resolution. It just takes years and years of work. It's very expensive. You end up with a bunch of experts that you can't replace. And what happens is, and I know this having built now our own six generations of entity resolution, is you get to a point in accuracy and capability where you realize if you want to get that next 1%, it is so expensive, you almost have to rewrite it. The third category is legacy commercial software that's specializes in entity resolution, and these are popular commercial products. I had been building these myself all the way up through generation 5, and what these technologies tend to have is you still end up with specialists. You still have to train and tune with as you have more data sets, and as the number of data sets and the size of the system grows, the complexity of running the system and combining that new data, that complexity just gets higher and higher, and it just makes it a very expensive proposition. And that's really what we've done differently with the Senzing software developer kit that's running in Linkurious. Is it helps organizations now combine data easily without all these experts, and supports all these things like arrays and complex names. Now let's take a look here. I've highlighted these first set of bullets about the kinds of things you'd want in an entity resolution system. You not only want to be able to find duplicates within a system, but you want to combine data across sources. You want it to work across languages. You want it to be configurable. Accuracy is, of course, the most important thing. Making something accurate at small scale is a little easier. Making it accurate when you get to hundreds of millions or a billion records is harder. Making entity resolution explainable, that's actually something that's pretty tricky that some systems are unable to do. Being ready to run in the cloud, real-time, low latency, where you can entity resolve records, learn who's who and who's related in sub-second. And the hardest thing of all is making it easy to use. Now, these numbers that I've come up with, I've tested these with other CEOs of entity resolution companies, and there's some consensus around this, but for $1 million, maybe that list above, you can get to 70% of that. And for $5 million, maybe you can get to 80% of that. But no kidding, you could spend $30 million US and maybe get to 90% of that list. And I will tell you that today, that's not even commercially leading product. It just gets so expensive. And this is just so often underestimated. It just seems like you're making progress, but as you get closer and closer to higher quality and more scale, it just gets harder and harder to climb that hill. And I think, so this chart's mine as well. And so, one of these popular graph databases, in fact, the leader maybe today that we all look to is Neo4j, and I'll just talk about graph databases in general. Is a lot of companies are trying to build the entity resolution as native artifacts in the graph, and we're just not seeing that work out. It turns out there's too many little problems you're trying to solve, whether it's arrays of addresses, names, and phones, whether it's the spelling variations and how to compare 5-part Spanish names versus a Cyrillic Russian name are just totally different methods. Comparing messy addresses that first have to be parsed right to even compare them are these primitives that are hard to bring it all together and have that be performative in the graph. So we've really not yet seen any really high quality entity resolution coming out of being built in the graph first. You can do these prototypes, you can get things running, and you can say you're making progress, but I kind of joke about it. It's kind of like climbing trees to get to the moon. You'll watch somebody climbing a tree and you go, "What are you doing?" They go, "We're going to the moon." You stand back and look, you go, "How's it going?" They go, "Look at the progress we're making," as they inch up the tree. But you stand back and look, you're like, well, they are not going to get to the moon. And that's what we see happening when people are trying to prototype and build entity resolution natively in the graph. Gene?
And we have seen that firsthand actually, and that's why we have decided to partner with Senzing to provide some real entity resolution capabilities within a product. So Senzing, as Jeff mentioned, is really a purpose-built AI for real-time entity resolution, and it's based on an entity-centric approach. And Jeff will talk more about that later. And starting this quarter in beta, Linkurious is integrating and shipping to its clients Senzing to perform entity resolution on top of graph data. And the Senzing entity resolution process does two things. It finds and consolidates duplicate entities, even if your data is messy. And it also discovers hidden connections between entities. The entity resolved knowledge graph that are produced via Senzing can help investigators understand their data faster and find relationships that would otherwise have been impossible to identify. I want now to talk a little bit about how it works behind the scenes. Here you can see a bit of an overview of that. The starting point will be for an administrator to configure the mapping between the data that's in Linkurious Enterprise and the underlying graph database and the Senzing ontology. So that will be done via a no-code UI that I will demonstrate in a few minutes. Then the data is ingested in the graph through an ETL process, and the data is sent by Linkurious to the Senzing engine. And after that, the Senzing engine detects entities that are duplicate entities and adds some Linkurious connects these duplicate entities together in the underlying graph database. The net result is that for the end user, directly within the context of his or her investigations, he can or she can identify these duplicates very quickly and in very visual fashion. So that's what the integration looks like, and we are very excited by this for a couple of reasons. First, because this integration, this ability to entity resolve graph data is completely graph native. You don't need to add any other components beyond the Linkurious platform and the underlying graph database. You also don't need to have any entity resolution expert on deck, on staff to make the system work. You simply need to deploy an extra component within the Linkurious architecture via a simple Docker command. And because it's graph native, because you don't need to have expensive trained entity resolution experts, we think that it's very attractive in terms of cost of ownership, especially compared to some of the legacy solutions out there, or compared to building something bespoke in-house. And I think Jeff shared some numbers that are definitely food for thought earlier. And because our clients are struggling with very complex data changes, we have also built this integration with speed and scalability in mind, and with the intent of having something that works in continuous real time. So whether you are working with a couple of thousands or hundreds of millions of records, whether you are doing occasional batch load of data or you are streaming in real time, the system is simply going to work. We have also added some explainability to the implementation, so that it's possible as an end user to understand why two records have been identified as connected. And finally, the system is self-learning and self-correcting, and it's been built with privacy by design. For example, you can deploy that on-premise, and no data is going to leak to the outside world, giving you a lot of control on your sensitive data and sensitive processes. And now over to you again, Jeff, for a more fine-grained analysis of entity resolution.
I call this entity resolution in slow motion. I spent 30 or 40 hours to create what I would call these 10 moves. Let's take a look. Look at these three records and ask yourself, if you had these three records in hand, would you determine these to be one person, two, or three? And I could give you a long pause. Sometimes in public settings, I would have votes. How many people see one, two, or three? By the way, by the time I get through all 10, the number's probably only 2 out of every 1,000 people get all 10 moves right. Anyway, with this data presented, you would be fairly safe to assert that the three records are really the same person for the reasons highlighted in the blue. And so this would be an example of fuzzy matching. Now take a look at this record. It's got the same email, but the name is different. So some systems that use keys might take emails and just try to combine them if the email is the same, but you can't do that. This would be a husband, well, probably a husband and a wife sharing the same email. But by the way, if that said William Smith on record 4, you would actually be able to put them together. It's why understanding the deep nuances and similarities in names. But given this, you actually have to graph it because it's a separate entity. So record 4 becomes a member of entity E2. Now, number 5 happens in data. This is just what we would call a disclosed relationship. As they told you, it's the spouse, it's the joint account holder. So there's no entity resolution work to do there. But I just introduced that as another form of a relationship. Now, let's take a look at record 6. What would you do with record 6 considering the other records on the board? And if you looked close, the name is, of course, Bobby versus Bob. That's good. The date of birth's the same. But on a name and date of birth, really risky to put them together. You get too many false positives. So in fact, you have to hold them apart and call it a possible match. And so Senzing does that, as you might expect. Now, how about this? This took us, it's embarrassing, but it took us decades to be able to do this at scale. And here's why. Look at this. This record shows up with just Smith at email. It's the same as record 1 and 4. But who is it? It could be either. Some systems, I'll say incorrectly, if record 7 just had the word street on it, as if Patricia didn't live on a street, would automatically combine 7 and 1. But what you have to do in this case is you have to hold record 7 out. And we call it a type of possible match that's ambiguous. I'll tell you, if E2 didn't exist, you could have great confidence that record 7 belonged in E1. And if entity 1 didn't exist, you could have great confidence record 7 belonged in E2 with 4. But they both exist. By the way, the boxer in the US named George Foreman named all 5 of his boys George. So if you get a George Foreman with a home address and a home phone, you don't want a new record to arbitrarily match to one of the 5. You actually have to hold it out like this. The trick about this is if E2 didn't exist, like record 4 hadn't shown up, and record 7 was sitting in here, the moment record 4 shows up, you have to pull 7 out because you've learned something. That's the kind of self-correction and real-time learning that Senzing does that is very expensive, and sometimes you would just have to start over when you realize that. Now, moving along, let's take a look at record 8. What to do with record 8? Oh, I wish I had the time to have the show of hands to see what you think happens next. But I'll tell you what's going to happen. Record 8 is really entity E1. It's going to match in here. But something else is going to happen. The moment record 8 lands, it's going to learn something new about E1. It's going to learn this email address right here, bsmith@work. If you knew that entity E1 had that email address, this record 6 that had a name and a date of birth only, if you knew that it also had an email, you would have been able to not make it a possible match. It would be a match. So what Senzing does is the moment record 8 lands, it automatically fixes that possible match and corrects it in real time at thousands of records a second. Now here comes record 9. We only have one more move, by the way. So record 9, who is it? Well, it's quite a lot like record 3. But if you look close, the date of birth is 54 here versus whatever it is over here, 78. I will tell you that record number 9 is going to appear here, right in between entity E2 and E3. But something else is going to happen. The evidence of record 9 is going to tell us that record 3 didn't belong. It was actually a false positive. So watch this. Record 9 lands and 3 is pulled out. I just want you to appreciate how hard this is. You've loaded 100 million records or 1 billion, and you get 100,000,001. And you say, where does it belong? The moment you figure out where it belongs, you have to ask yourself, now that I've known that, had I known that in the beginning, would I have made any decisions differently? We call it sequence neutrality. Did you get record A first, then B, then C, or record C first, then B, then A? And when you're sequence neutral, it means no matter what order they arrive, at the end state, when you have all three records, your end state is correct. And so your entity resolved graph with Senzing in Linkurious is doing this type of real-time self-correction, and this leads to the epic accuracy that outperforms humans regularly. Okay, record 10 shows up. Again, I wish I could just take a show of hands. But if you were to look close, record 10 doesn't match any record here. It doesn't match record 1, although it has something similar with the street. It doesn't really match record 2, although the phone number is the same. It has a little piece that matches different records. But systems out there, most systems are doing record matching. New records try to find an existing record. Turns out that's old school, bad practice, and you can't find clever bad people because clever bad people don't use the same name, address, and phone on every record. So record 10 is in here because the features of record 10 aren't trying to match records. It's entity-centric learning, means entity E1, we're learning every name, including the AKAs, every address, every phone number around that entity. So when the new record 10 shows up, we're matching it to the union of all the features in E1. Okay, now, well, we're basically done, but for GDPR and other privacy laws around the world, what happens if you need to remove record 8? The Senzing entity resolution does this in real time. If you delete record 8, it realizes that it doesn't have the evidence anymore to prove why record 6 was the possible match, and it doesn't have the evidence anymore to be confident that record 10 was a member. And so it undoes those and moves those back to graphed relations. Senzing supports these other languages. And I think, am I doing this chart, Sean, or are you?
You are doing this chart.
I'm doing this chart, great. So I just to re-highlight the importance of record matching versus entity-centric learning. If you have this new record show up here, it didn't match this, that, or this. And so these systems that do record matching will take this record and determine that it's a new record and a new entity. In entity-centric learning, it's going to realize that all these records are combined, and it's matching this to the features across those. And then it will actually put it in and combine it into that record as well. And for all the bad guy hunting missions, risk, fraud, where people are trying to intentionally deceive, this is a fundamental essential in all fraud systems. And it's taken us decades to really get it right. It's taken decades to allow it to do this entity-centric approach at the scale of literally tens of billions of records. Okay, with this, back to you.
Thanks, and very exciting. So to put all of that in context, I'm going to show a demo. And for this demo, we are going to use the Panama Papers data. Specifically, we're going to use the ICIJ offshore database. The ICIJ, for those of you who don't know, is a consortium of data journalists. They have investigated a lot of data leaks, I guess the most famous one is the Panama Papers. The ICIJ is also publishing the ICIJ offshore database. It consists of 5 data leaks, and these data leaks, these various data sources, are covering more than 400,000 addresses, 800 and more than 800,000 entities, more than 700,000 persons, and 26,000 companies. So it's it's not a humongous data set, but it's definitely large, and it has the particularity of being particularly messy because it's data leaks. It's not clean data that's been cultivated by one company. It's just data that has surfaced and ended up in the labs of the ICIJ. Another interesting feature of this data is that a first level of entity resolution has been performed by the ICIJ using very simple and effective approaches, basically mostly looking at similar names. And it will also provide us a bit of a benchmark that we can use to compare with the accuracy of Senzing. So first, here's a bit of an overview of the core data model. So you can see up top we have an address, and that address is connected to a company, and we have two persons that are the officers of the company and connected to the company. So this would be the data, at its cleanest, at its purest, it's people, companies, addresses. And then, as mentioned previously, the ICIJ has performed some entity resolution, and this is materialized by relationships. So you can see that we have two Matthew Joseph Bryant here, and the ICIJ has added the same name as relationship between the two records to materialize the fact that they are related. And as part of the demo, we have entity resolved the data using Senzing. And this extra information will be overlaid in the data with that sort of green node that you can see here. It's a sending node and a resolved node that is connected to the two records that are related to the same real-world entity. So that's it for the data that's in the graph. And now a quick overview of the results of entity resolving this important data set. So the starting point, I guess, is that there are almost 2 million records in the original data. And specifically, it's 1,970,000 records. After applying entity resolution using Senzing, we end up with less records. We have actually 1,890,000 unique identities within this data set. What that means is that there are some duplicates. Specifically, we have 130,000 duplicates, and the compression rate is 4.1%. That means that if you take a random sample of 100 records, you will really have 96%, and the rest will be some noise records that are actually related to the same real-world entity, but that are simply duplicated. So that's an overview of the insights that have been provided by applying entity resolution to the Panama Papers. And now we are going to see this in action via a demo. So in this demo, we are going to look at the data, and we are going to see a couple of things. First, we will see how to map a data source and start the entity resolution process in Linkurious. We will also look at before and after entity resolution, what the data looks like before and after performing entity resolution. We will also look at potential duplicates and look at how the Senzing entity resolution performs against the ICIJ entity resolution process. Okay, so this is the Linkurious Enterprise UI. First, I'm going to open a visualization. Okay, so we have a sample of some records within the offshore database, and specifically we see that we have 62 records. So that's 56 officers and 6 entities or companies. And just from the look of it, just looking at the data like this, we don't see any obvious connections. It's really 62 distinct records, no connections whatsoever. Now I'm going back to the dashboard. And I'm going to use the newly introduced entity resolution capabilities of Linkurious Enterprise. And the first step of that process, of that journey, is to click here on Map an Entity. So we want to map the persons, and the persons in our graph are officers. We need to map at least 3 attributes for the entity resolution process to start. But the more attributes we map, the more accurate the end result. So let's start with the name. So we select here an attribute in the Senzing ontology, and now we match that with the relevant field within the graph, which here would be the name. And we can do that again, maybe this time for the address, country. Here I'm going to map, the address country field with the country that's in the address node connected to the officer node. And I'm, just going to add another random field, just for the sake of showing how it works. Now I'm going to click on Save Mapping. I've done my mapping, and now I simply need to click on Running, and I will be able to stream the data, entity resolve the graph, and add the relevant extra information to my dataset. Now going back to the investigation UI, I'm opening again my visualization, and I'm going to select everything I can see in the visualization, and this time I'm going to retrieve the newly added Senzing nodes. Zooming out a little bit now. Okay, so I guess there were 14 Senzing nodes, and what that means is that we really don't have 62 completely unrated records. We actually have 14 clusters of rated nodes. And I can zoom in on one such cluster. We have 2 cheat records. And we can compare these records. They have different IDs in the original database, but they have been collected by the entity resolution process into a single record. I can also see why that result here. There's a match, I guess, in terms of name and address, and here it's just initial. I can zoom out. I can also use the recently introduced grouping features to further simplify the visualization. And instead of dealing with the various records, I can further streamline the visualization and just group things together based on the entity resolved entities. And I can see that they are brought together. It makes the overall visualization and investigation process much easier to accomplish. So here we can very quickly, very easily see the impact on the noise reduction that's been accomplished by entity resolution. We've been able to pivot from 62 distinct records to 14 clusters, and it helps understand the underlying connections in the data. So that's one first example of the value of entity resolution. Now I'm going back to the dashboard, and I'm going to talk a little bit about false negatives. Okay, zooming in on some subgraphs now. So here we have 2 records, 2 Peter Michael reader gaze. They are connected by as same name relationship, and that's the result of the ICIJ entity resolution process. Same name, they have been identified as duplicates. So far, so good. But I can see that they're connected to a Senzing node, and that this Senzing node is connected to another record, another Peter Michael gaze, except that this name is spelled a little bit differently, and as such, it hasn't been connected to the other nodes. So if we hadn't performed entity resolution using Senzing, we would have two clusters. We could be looking at this information there, and we would completely be oblivious to the information that sits there. But because we have performed entity resolution, we are able to quickly go from these two records to the other one here, and have a more holistic understanding of the data. So that's one example. Here we have another example. So we have cock wing junior limb and cock wing limb, slightly different names. As a result, they haven't been connected by the ICIJ entity resolution process. But you can see that both of these persons are connected to an address here. They are also connected to a company there. And as a result, there's a very high probability that these are actually one and the same person. With the use of Linkurious Enterprise and Senzing, we can connect these two records and basically get to that insight. So that's the value of using world-class entity resolution like Senzing. It really helps make sure that these corner cases that Jeff was talking about in entity resolution in slow motion, we can get them right, and we can find as many of the connections that exist in the data, as many of the duplicates as possible. Going back to the dashboard now. One final thing that I wanted to mention is that it's possible to use the Linkurious alerts to automatically monitor the data, detect clusters of connected records, and then review those. Here we have created an alert that basically surface any cluster of connected records, and we can click on one such cluster, look at what's happening, and make comments, add insights, add human insights regarding the entity resolution process. Going back to the dashboard now. So that's it for a quick demo of the integration of Senzing in Linkurious Enterprise. We have seen a couple of things. We have seen how to actually activate the entity resolution feature. First mapping the data, then executing entity resolution. We have seen also the before and after effect of applying entity resolution to the data. And finally, we have seen some examples of the sort of corner cases that the entity resolution performed by Senzing can help detect versus other methods and approaches. And now back to the presentation. Okay, and before wrapping up and taking questions, I wanted to share maybe a couple of thoughts regarding what to look for if you are considering adding some entity resolution capabilities to your decision intelligence setup. One such question to ask yourself as you are looking into various options is how easy it is to integrate with other capabilities. Are you already buying just one specific entity resolution piece, and then you will need to do a lot of engineering and investment to integrate that with other capabilities? So that can be a very big challenge. And with our product, with our offering, it's very integrated, very easy. You simply need to push the data to your Fabric Graph database, and then you can leverage the full suite of capabilities in Linkurious Enterprise, including alerts, scoring, investigations. All of that is directly integrated with entity resolution, meaning that there's no big lift to integrate all of that together. Another very important aspect is how complex it is to add a new data source. So you have found maybe an approach to perform some entity resolution, but how is it going to work as you add 1, 2, 3, and more data sources? With Senzing principle-based entity resolution and with the no-code UI that I just showed, it's very easy to add new data sources and for those data sources to be entity resolved. You don't need to do a lot of training and tuning. You also don't need any entity resolution expert on staff. It's very easy. You simply need to push the data to the graph, do the type of mapping that I demonstrated, and you're off to the races. Another aspect is the actual accuracy of the entity resolution results. Senzing integrates specialty comparators with advanced knowledge of attributes like phone numbers, social security numbers, dates. So, for example, you have access to information about what are real, realistic social security numbers, what are not realistic. Same thing for the phone numbers. You also have dedicated libraries for names and address comparisons, which in itself is a big challenge, parsing and making sense of addresses. Another important aspect is can your setup work with real-life data, aka messy data? And here, entity-centric learning can really help because it learns from nicknames, typos, address histories, alternate email addresses, and more. And that richness, it enables the detection of weak signal in a way that Jeff illustrated in his entity resolution in slow motion slides. And another aspect, which is very important, is can your setup react to new information in real time? Are you able to use new observations to reverse earlier assertions in real time? And with sequence neutrality, you can ensure that the outcome is the same whether record A was reset first, then B, or record B, and then first and then A. And as a result of that, as a result of the ability to react in real time as new records are added to the graph, you can react. You don't need to do a big reload of the data, and it's super important in mission critical use cases. So, for example, if you want to detect in real time a fraud case, a sanctions evasion risk, that sort of use cases. And finally, it's the explainability of results that is truly important to consider. And our solution provides transparency on why each record has been resolved, and that acts as a way to empower the human analyst. They can look at that and figure out whether this is indeed correct or not. There's no black box effect that would really puts the human analyst in a difficult position. Here it's very transparent, and as an analyst, you can ultimately make an educated guess in terms of the entity resolution process. And now time for questions.
Thank you both. So we have a few questions here in the Q&A. If anyone has any other questions, don't hesitate to drop them in, since we have a little bit of time to answer your questions here at the end. Jeff, I saw you kindly answered Shriharsh's question in the Q&A panel, but it's not published, so I'm going to ask it again if you don't mind answering it, so that everyone can hear the answer. So we had a question come in. Could you lay out the different generations of ER applications?
When I thought about that question, I thought about that in some different dimensions. There's been like one set of generations of technology, or like batch entity resolution. You get an answer, and then once a month or once a year or once a quarter, you rerun the whole batch. So batch converting into real time, I think, has been kind of generationally different. Another one is the most of the engines have to do with weightings and training and tuning. If you have a name and a passport, but the date of birth disagrees, what do you do? If the name of the date of birth's right, passport's right, but everything else is different, then what do you do? Okay, you still put them together. And it's doing all those combinations. As you get more data sources and more features, it gets more and more complicated. So the cost of introducing each new set of data is more expensive. So the transition from rules training and tuning to principle-based entity resolution, which was really the big discovery that we had when we built Gen 6 at IBM before we spun it out. The next that I mentioned was typically entity resolution. It's a stack of moving parts to make it work, and to compress it down so that it's composable, so you can just combine it into other things with ease, means less moving parts, less points of failure to break, easier to deploy in secure environments, easier to maintain security patches. So entity resolution as a pure SDK, I think, has been a leap. And then another one is most entity resolution technologies are figuring out who's the same as who, but not also solving who's related to who. And if you understand the relationships, your accuracy gets better. So entity resolution with, and when we use the words entity resolution, we mean also building that relationship graph. So that there was really an era where that didn't exist. It exists today. And so those were what came to mind on that question.
Thank you, Jeff. So we have another question here from Oli. How does Senzing optimize the trade-off between false positives and false negatives, given that depends on the dataset scope and context?
By default, and you can change the default, but Senzing favors the false negative. If it's highly confident, it'll put them together, which means a false positive would be very rare. Otherwise, what it does is it puts it in the possible match category. And then as new data arrives, as you saw with record 6 and 8 in my slow motion, as you layer in more data, it then improves the quality and it will promote possible matches to matches. Now, if you were to use Senzing in Linkurious in deployments that are maybe just for marketing, you could soften it up a little bit because you're not making any big decisions. You're just deciding whether to send me a hair care product or not.
Thank you. All right, we have another question here. Does the platform support multiple languages like Arabic or Chinese?
John, you want to take that or you want me to take that?
I think it's best if you take that one.
Okay, great. Yeah, at Senzing, we've spent a lot of money over the years building entity resolution that supports various scripts from around the world. And it's an area that we continue to invest in. Just in the last few years, we've hired linguists to do the Burmese and Khmer script. Khmer is from Cambodia. And so those things are all pre-built in to match within those scripts and across the scripts.
Perfect, thank you. So there's a question here from Joseph. What kind of preparation or data cleaning is required before using the entity resolution features?
Very little. You basically need to push the data to the graph, and then that's about it. You map the data in the graph with the Senzing ontology. And I want to highlight that Senzing that does a lot of heavy lifting in example in terms of parsing addresses, but it's really, really simple to load new data.
Super, thank you. All right, a couple more questions here. What kind of performance can I expect for processing large data sets? Are there limits on volume?
Did you want me to take that on
Yep.
this, on the resolution side, or do you want to take it on the whole thing?
Take that on the entity resolution side, and I will complete.
Okay. From an entity resolution standpoint, you do need, for entity resolution to be fast, you have to have high-speed drives, not spinning disks, and you have to have them close to where the processing is done. Assuming you get that architecture and that hardware provisioned correctly, we have people today running production systems with billions, even tens of billions of input records, and doing thousands of new entity resolutions per second where every new record also fixes the past and gives you an answer sub-second. So that's the kind of scale that we're seeing in production.
And that's consistent with the scale of our current clients. We have clients with data sets in the billions of records. In the first iteration of the integration of Senzing, we will not be able to match the sort of capabilities of performances that Jeff just highlighted, but the intent is definitely to get there over time, so that we can support these clients with billions of records in production and the need for real-time analysis.
Thank you both. All right, there's another question here from Oliver. How does your solution compare to a product like Quantexa?
Jean, you want me to say a word on that?
Yeah, sure.
Yeah, I'd first say that technologies like that are cars. When I think about Senzing itself, I think about Senzing as a transmission. So ultimately, Linkurious has a product in the market that competes with companies like that. Whether it's the company that you've asked about specifically, or the suite of other companies out there that have entity resolution in their products, when a product like Linkurious has Senzing inside, what you get is the speed of deployment, the speed of combining data sets and seeing results is maybe an order of magnitude more quickly or more. And the accuracy out of the box probably will outperform the heavy tuning that's required on these other engines. So I think that the customers of our joint product are going to be really pleased with the speed of the time to value. That's my side of that. Jean, you want to take any other aspect of that?
I simply encourage anyone interested in testing all integration and the combination of Senzing and Linkurious to reach out. We are very confident in terms of the performances and the value that we can deliver.
Thank you both. So 2 more questions. How long does it take to do POCs and see some results?
It's really a matter of days, weeks, I guess. If you have access to the data, or even better, if it's already in a graph database, it's a matter of hours, to do deployment of Linkurious and Senzing, do the mapping, and start entity resolving some data.
Thank you. All right, a last question from someone who might want to get started. How easy is it to start using entity resolution in Linkurious, and how could I get access?
It's very easy. We are starting the beta in, I think, 1 week or 2, and the easiest way to get access to that as soon as possible is to reach out to your contact person at Linkurious. So if you are already a client, reach out to your customer success manager or account executive. If you're not, you can simply drop us a line at contact@linkurious.com.
Thank you. I promised just 2 more questions, but there are actually a couple more questions that came in, if you guys don't mind. So there's one asking, do I have to buy Neo4j, Linkurious, and Senzing?
So if you already have a Neo4j license, for example, then that's fine. There are no extra costs that are implied there. And if you want to activate the entity resolution capabilities in Linkurious, the great news is that we will have a free tier with a significant amount of records that you get access to for free, simply by deploying the product. And then there will be additional charges for larger data sets. Once again, I encourage you to reach out either to contact@linkurious.com or to your contact person at Linkurious to get more information about that.
All right, and one last question from Justin. With Senzing's constantly evolving / changing results? Does it generate timestamp snapshots? For example, if an investigator sees a result that links 2 records as an entity on one particular day and makes decisions based on that result, but new records arrive later that in fact indicate the records in question belong to different entities, how is this handled?
While we do have a customer that snapshots every decision at every point, it becomes very expensive if you have a very large set and your investigations are around a smaller universe. What is the more popular and maybe what I would say best practices, if you're deciding to make a decision, you're buttoning up a case, you're making some final decisions, you would actually snapshot it at that time and then carry that along in that investigation with you. That would be the best practice.
It's consistent with what we have seen. Typically, our clients are doing snapshots. Could be an extract in Excel format, in a PDF format, in something like that when they are, for example, starting a criminal case.
Perfect. Thank you both. So thank you so much for the audience for all of the questions. Really great to have that interaction. So that's it for today. Thank you to both of our speakers, and thank you so much for everyone who joined us. And we'll see you at the next webinar.
Thanks, everyone.
Thank you. Bye.